Hola. Okay, this is what I know about Spanish, sorry. I'm about to show on this presentation a lot of new concepts and a lot of code. So please bear with me. I hope we're gonna have fun on the next 25-ish minutes, and hopefully we can learn a trick or two. Before everything, a small disclaimer. All of these proposals I want to show you are under construction. So the main intention here is to help you to understand the base use case of those proposals and the pros and cons of each one of those, and create some awareness regarding the tough work that TC39 is doing in order to push the JavaScript, ECMAScript specs to the future we want. That said, I present to you my talk. Back to the future. So, I'd like to start my presentation with asking a very tricky question. What is this? In ECMAScript, this has a different semantics than this in many other languages, which often refers to the lexical context. I'll explain. So in the global scope, this always refers to the global object, like Windows in the browser, and self in web workers, and a little bit different in Node.js. It points to model exports. But what about inside a function? Well, it depends. It depends how the function is called. I will show some examples. So if I run this code, you will see that you always receive the global scope as the result. So in the browser, the global scope will be the window, but in Node.js won't be the model.export anymore, it will be just the global object. When you use a new operator, it does something different, because the new operator, among other things, it bounds the value of this to the newly created object. So then in this use case, I'm setting the property called bar to this, and because I'm using new full, it's not easy to see there, but like trust me, it's object just bar bus. And this is a mistake I did a lot when I was starting and coding JavaScript, calling a function without new, and then try to figure out where the bar is, and actually it wasn't the global scope because I didn't call the function with new. So take this in consideration. So then with the introduction of ECMAScript 5, we have the strict mode, which acts a little more different. Because in strict mode, the this variable doesn't carry implicitly the value. So it means if I call this function as it is, I will receive undefined, which is the full value of this in this example. So how can I set the value of this to a function? So I'm pointing out some example. So the first parameter of function call, function apply, and function bind is the context. So whenever I pass as first parameter to those functions, it bounds as a this value. The new operator, as I told you, and whenever you place this function inside as a member of an object, the this of this function will be the object itself. So just as example, I'm just using this full function again, and then you can see by the following lines from the line 8 to line 13 that you will see how is the returning value of each of those calls. As you can see, understanding the value of this could be tricky, but somehow we can make it predictable. via using function.bind or arrow function. The method bind permanently binds the function to the first given parameter, return a new function with this bind to the first parameter. And arrow functions works a little bit different. It keeps the value of the lexical dis of the surrounding context. I will explain this with the following example. So I create this meout component, which is just a class which has instance value called Paul, which I'm point to the button on the first line. And then I have the meow method, which I call whenever I click on the button, which is described on the line 15. So the problem here is whenever I click on the button, the dis inside the event is the target element of that action. So the console on this line 9 will output undefined because the button element doesn't have the property Paul. So I can rewrite this last line, binding using the method bind to bind the instance cat to that method. It solves the problem. Or I can use an arrow function that will get the surround context, a lexical context, and it will not create like a new context inside the function. Although arrow functions solve the majority of the use case that we need to explicitly bind these, we still have two use cases that we have to do this. I'll explain it now. The first one is whenever we call a knowing function. In this example, I have on the line 2 an object called obj, which I don't extend from object.prototype. But then, in the following line, I want to try to check if the obj object has the property x, which will throw a type error since it's not extending the object.prototype. So what I'm doing here in following lines is I'm taking this method from the object.prototype and then use the function prototype call. Again, passes the first parameter explicitly the context, which is the object, and then the parameters for calling this function, which is kind of tricky to understand whenever you are writing this code or reading this code. So the second use case is, as we showed on the meout component example, which is whenever I want to extract a method from an object and use this as an argument. So how could I solve these two use cases? So this is the hook for present you the first proposal of this talk, which is bind operator. So the bind operator has introduced a new token, which is this double column, and which acts as a syntax sugar for the two previous use cases. It introduced the two forms of this operator, the unary operator and binary operator. The unary operator just bounds the provided reference, the base of the provided reference as this variable, as you can see on the line 2 and the last line there. And most importantly, the binary syntax creates a function such as the left side of this operator is bound as this of the right side. As this example could show you, it's easier to understand, right? So aside of this, the bind operator can bring us new opportunities to create a virtual method to compose functionalities less, in this example of an hypothetical interrupt lib. Or in RxJX5, they have they introduced this syntax as well, but they remove on 6. But you could do this there. Or even another example, like in a jQuery-like library, you could just extract the functions that you need and compose those to do whatever you want to do. This is super cool because it creates a new way to compose functionality via virtual methods. So I just spoke about the benefits of having virtual methods for composition. But with bind operator, I have to rely on this to be bound to my function in order to compose this. But what if I don't want to rely on this? I don't want to use this inside my function. So before I introduce our next proposal, I want to dig more into this example. So let's suppose that we have a request for the manager to create a function that sanitizes text input from the user, and then transform all the number symbols into its textual representation. Usually, the way we would achieve this is by write this kind of code. But then, to make it readable, we need to create all of these intermediary variables. We could just remove those variables, right? Let's see how this looks like. So, yeah, it's hard to read because it doesn't feel idiomatic because you need to, instead of reading from left to right, up and down, you start to read from the most inner line to the most outside line in order to understand what's the data flow of it. So how can we do this in a better way, let's say, without this complexity or that intermediate variable? The answer for this use case is pipeline operator. Okay, so the pipeline operator is a syntax sugar for those use cases. It creates a way for to do a streamline of a chain of functions in a functional manner. It is backwards compatible and provides an alternative for extendability in prototypes. I can explain. So, in our previous example, this snippet could be rewritten using pipeline operator from this to this. So, let me explain you in short what it is. So, the first line is the topic of this pipeline chain, which will be inserted as a parameter to the next step, and then the result of the next step will be the topic for the following steps. And then this code will be the sugar to this one, which is, we don't need to know because just the browser will read this code, not us. Okay, but what if my chain function needs to have one more parameter? Because in that example that I just showed you, just receives just one parameter. So let's suppose that the textualized number function has a second parameter, which is a list of the numbers that needs to be textualized. And our manager asks us just to textualize zeros and ones. So how can we do this with using pipeline operator? So we can use arrow functions to achieve that. The problem is, on the minimal proposal, we have a small syntax overhead because we need to wrap arrow function with parentheses. But what if my function, what if I need to sanitize my function, I need to send this to the server side. So we can use a wait for that. But the problem of it is this line. It's tricky because we don't know if this line will be desugared to this one, which is I call the sanitize function with the given parameter, and then I await the result of this, or I await for the sanitizing function to be resolved without any parameter, and then I receive a function that will call with the previous topic. It seems that minimal propose has some issues to be solved in order to have the syntax and semantics specs accepted. So how can we address those issues? To explain you and how this is being addressed right now, I need to introduce you for the two competing proposals that are trying to solve this issue. The first one is Smart Pipeline. The Smart Pipeline proposal, we can address the previous issues with this snippet. You can check the last line of code is the bear style, and the other two are topic style, which means in the topic style, I have a token, which is my wildcard, that will be replaced by the topic of the previous step of this pipeline chain. And then whenever it's kind of implicit, it's just a function that receives one parameter, I can use the bear style. We have some rules for that. Whenever you need to use parentheses or square brackets, you need to use topic style. Otherwise, you have a type error, syntax error, sorry. And the sharp token it's not final, it's just when the current proposal is still subject to change. So what about currying? So since you cannot use parentheses on bear style, if you try to use a currying, you have a syntax error. So you need to use a topic style, which is the second snippet there.
Here comes a new challenger!
So the other competing proposal is the F# pipeline proposal. It just extends the minimal proposal with a wait step. And basically, the wait step just awaits for the resolution of the previous steps in order to go to the next one. So given our basic example, you can check here that in the third line, you have just like a single await step, which literally means that I need to await for the previous step to be solved in order to go to the next one. But then you can see that it doesn't address the let's say, overhead of wrapping an arrow function with parentheses. But we will go to this talk little soon. So this is the binary operator I forgot to mention is in stage 0, and this one is in stage 1. So when we were discussing the pipeline operator, we saw this example with a pipeline step that has a wildcard there, and then once the computed value of the previous step is done, it just replaces there. We can call this partial application, but what is a partial application? So partial application is refers to a process that, given a function with n arity, it returns another function with a smaller arity by bound some parameter to a fixed value. Arity by it's the number of parameters that a given function receives. You can check the arity of a function just by calling the function dot length. Then you have the. So given this small example, I can call the function directly. But if for any reason I have only the two first values beforehand and the third one will be available inside the resolved premise, how can I do that right now? So I can achieve this by doing this, but I would say it's kind of verbose because we need to create two variables to hold these values until we have our params be resolved, so then we can call the final function. But I think we can do it better because we have a way to achieve a partial application right now in ECMAScript, which is achievable by the function.prototype.bind. And it's tricky because oftentimes we think that the bind just works for bind the context, but the bind method accepts more parameters, which is the first one is the context, and the following parameters are the list of arguments that we want to bind to that function. So I can do this in this manner, and in the first line you see that I'm create a new function called say hi to location, and then I have the function which I don't bind any context, but I bound the two first parameters, first to hello, the second to Maria, and then I have this new function that I can call afterwards inside my resolved promise. But there is a problem with this, because what if I have just the greetings and the location, which is the first and the last parameter beforehand? How can I bind just the first and the last one? I cannot do this with function.bind, because it just binds from the left to the right in order without jumping any parameters. So someone can say, yeah, what about currying? Yes, we can achieve a partial application with currying, although we can do this. Currying is very different. It's different than partial application, because currying is a function that, given a function, if arity n, it returns another function with arity n minus 1. So in this example here, I'm doing this currying stuff, and then, yeah, it works. But still verbose, because whenever I want to have some kind of different order of the parameter, I need to rewrite this function in different order. How can I do this without currying? Okay, we can try arrow functions, right? So as you can see, there are a lot of ways to achieve partial application in JavaScript, but none of them in a standardized way. So that said, I want to introduce you the last proposal of this talk. Partial application. So the partial application proposal creates two new tokens to be placed inside a function, which allow us to partially apply arguments to a specific function. So question mark for single argument, ellipsis for multiple arguments. Ellipsis is not in the initial spec anymore, just to make it simple. I can show you later. Let's check how it works. So this is how it works. Whenever you create a partial application, it bounds the fixed parameters to the arguments, and then returns a new function, in this case with hello and Maria bound, and then returns a new function with the remaining parameters that you can call later. The good aspect of it is that it's clear to the developer how many parameters are needed in order to call a specific function, which is not the case of currying, because you don't know whether the next call we just returns a new function or call the target function. Let's see more example. So as you can see there, it becomes clear to the developer how to bound arbitrary parameter without adding any extra code to handle that. It's just like replacing the token in different places. But wait, there is more. Our initial example was based on this template string, right? That just like we have a function that receives the parameter, and then you just console those. It turns out that placing the question mark token inside the template string, it transforms this template string into a function that you can call later, based on the missing parameters. Super nice, isn't it? So let's talk about the ellipsis token. The ellipsis token just spread the unbound parameters there. And it works and whenever you just want to bound just only the first or the last parameter, because it only allows you to place ons in the function call. So I have a small example to illustrate there, which is this function max greater than 0, that usually we can achieve by doing this. Whenever we send we call this function with numbers, it returns the maximum one, but then whenever we just send numbers below 0, it just returns 0. So this is a way to achieve that, but with the ellipsis token, we can just do like this. So you bound the first one with 0, then you don't care about the rest, and then you just call, doing whatever you want to do. So let's check how this will work with partial pipeline operator. So as you can see here, with the F-sharp pipelining, we still had this issue, let's say, not issue, but this overhead of wrapping an arrow function with parentheses. But if we have both in ECMAScript, we can do the following. Just place like replace that line with this one. So then, like this will be this will create a new function with the second parameter bound, and just expecting this first one, and then everything just works. Okay, let's wrap up. Should I use all of this in production? Okay, as you can see, there are a lot of aspects on those proposals that are still unsettled. The adoption of one could reshape the syntax and semantics of the other feature, or even remove it completely. So, should we use this in production? I would say not yet, but I encourage you to try out. All of those proposals have Babel plugin for those, so you can try it out, like do some toy example, try to understand what this is for. Choose what you like most, and then go to TC39 repository, put a star on the proposal you like most. If you have any concern, or you're just want to show some use case that you don't know how to cover, open an issue there, show your engage and be involved. These are the way you can follow me. This last one is an article I wrote on Smash Magazine, going a little deeper into bind operator. So I plan to do the same for pipeline operator and partial application, so you can have a material to refer to afterwards. If you want to send me mail or giving some feedback, Twitter, Medium, whatever. Thank you.
So much.